Using extensive observational data from the James Webb Space Telescope, a research team of the National Astronomical Observatory of Japan has examined the oxygen abundance in galaxies dating back approximately 13.3 billion years, roughly 500 million years after the birth of the universe. Their pioneering findings reveal a remarkable increase in oxygen abundance in galaxies during the first 500 to 700 million years of the universe's existence, approximately 13.1 to 13.3 billion years ago. This discovery sheds light on the fascinating process through which essential oxygen, crucial for Earth and life as we know it, was produced from the inception of the universe until the present day. In the early universe, shortly after the Big Bang, only light elements such as hydrogen, helium, or lithium existed. Heavier elements like oxygen were subsequently formed through nuclear fusion reactions within stars and dispersed into galaxies, primarily through events like supernova explosions. This ongoing process of element synthesis, unfolding over the vast expanse of cosmic history, is believed to be responsible for the creation of the diverse elements that constitute both our existence and the world around us. By observing the gas within galaxies, which are vast collections of stars, across cosmic distances, researchers can determine the abundance of oxygen in the ancient universe. Previous observations have already revealed the presence of abundant oxygen in galaxies approximately 2 billion years after the Big Bang. However, the light from galaxies that existed even further back in time is significantly affected by the universe's expansion, causing it to shift into the near-infrared range. This shift presents a considerable observational challenge. The research team utilized spectroscopic data from the near-infrared spectrograph, which commenced scientific operations in 2022. They achieved the identification of 138 ancient galaxies that existed over 12 billion years ago and determined their oxygen abundances. This level of analysis was nearly impossible prior to the launch of the James Webb Space Telescope. They developed and rigorously applied advanced analysis techniques to the data, conducting analyses on a scale several times larger than previous studies. The results revealed that galaxies spanning from the present to approximately 13.1 billion years ago exhibited little evolution in oxygen abundance when compared to the average of galaxies with similar properties, such as stellar mass. However, a significant discovery emerged among the most distant galaxies. Among the 7 galaxies discovered from 13.1 to 13.3 billion years ago, all 7 displayed an oxygen abundance level of roughly half or less than expected. For 6 of the 7 galaxies, there was a 95% or higher probability of a deficit of oxygen abundance. This demonstrates a dramatic increase in the abundance of oxygen in galaxies during the first 500 to 700 million years after the birth of the universe. The process of how oxygen was created and stored in galaxies has long puzzled scientists. The discovery of a rapid increase in oxygen abundance in the early universe, approximately 13.1 to 13.3 billion years ago, suggests that life in the universe might have emerged earlier than previously believed. If you found this exploration as fascinating as I did, give it a thumbs up. Share it with your fellow space enthusiasts, and don't forget to subscribe for more mind-blowing cosmic discoveries. Keep exploring the wonders of the universe, and until next time, stay curious and keep gazing at the stars. See you in the next cosmic adventure.